Hello, Assalamu alaikum. My name is Muhammad Ashiful Islam Sajid. My ID is 20201225. So now we're gonna talk about spatial awareness of cancer cells using segmentation. So in this topic, first I'm gonna talk about our introduction. So we all know that uh, what what is spatial awareness of cancer cells using segmentation means? It means the field of oncology has witnessed remarkable advancement in recent years, with spatial awareness of cancer cells emerging as a pivotal concept. In this concept, understanding the cell and the understanding of spatial cancer cells, uh, understanding the intricate distribution and arrangement of cancer cells within tumor is essential for tolerating effect treatment and are unraveling the complexities of tumor biology. Segmentation, a computational technique, has revolutionized our ability to dissect and analyze spatial information from medical image, providing invaluable insight into right behavior characteristic of cancer cells with their micro environment. Segmentation is the process of identifying and delineating regions of interest within an image and in the context of cancer research. The entails isolating cancer cells from the surrounding issues with advent of advanced imaging modalities such as confocal microscopy, multiphoton microscopy, and whole slide imaging. Research can now capture high quality image of tissue samples with expectation precision. Applying segmentation algorithm to this enable the separation of cancer cells from stromal cells, blood vessels, and other component of the tumor microenvironment. And now, in the next few section, we will answer that what is the importance of spatial awareness in cancer research technique for cancer cell segmentation, what challenges we will face in cancer cell segmentation, and our future direction in cancer cell segmentation. Thank you.
Assalamu alaikum everyone. My name is MD Fayyaz Ali and I am going to be presenting you about the literature review. So firstly, the authors explored the use of image processing techniques in construction projects. The employment image processing techniques for monitoring and assessing construction projects as well as inspecting infrastructure such as bridges and irrigation structures are highlighted. One key application discussed in the paper is the use of image analysis in grain-based industries for quality grading and classification based on kernel size, shape, and appearance. The use of image analysis techniques for monitoring the dimensional features of rice kernels during cooking is also discussed. Secondly, to analyze image in construction industry, various codes and algorithms are utilized. The segment images in the construction industry, image segmentation algorithms are employed. These algorithms divide an image into distinct regions or objects based on their characteristics such as color, texture, or intensity. Morphological image analysis is another technique used in construction applications. It involves the study of size, shape, and spatial arrangement of objects in an image. A novel approach to image-based rendering that focuses specially on reflection in a scene is explored. The authors propose a method called reflection space image-based rendering. that aims to generate realistic virtual images by accurately capturing the reflection properties of the objects in a scene. These techniques are crucial for understanding the behavior of cancer cells and how they interact with their environment, which can inform treatment strategies. By analyzing the spatial distribution of cancer cells, researchers can gain insights of how the cells grow and tumors spread.
Hello everyone, this is Gaurav Palgolpo. Right now I am going to present the methodology part of our thesis paper. My ID is 19101253 and the topic was spatial awareness of cancer cell using segmentation process. So we already know brain tumor is one of the prominent type of tumor disease where segmentation is done in multifarious ways. It's done through magnetic resonance image, which is shortly known as MRI. This segmentation will help is diagnosis and prognosis. Actually, prognosis is the part which takes place after the diagnosis. Just like I get any special features, just like brain glioma or something else, and after that, what the necessary steps will be done is included in the part prognosis. Moreover, tumor density measures and overall growth projections can be made. Several challenges were faced during this research. Some of them are brain tumor segmentation problems. Although brain tumor segmentation has great potential, there are some obstacles to overcome. So the challenges are lack of annotated data, and medical photos are prone to noise and abnormalities, which can make proper segmentation difficult. This may be brought on by things like patient movement, technical restrictions, and imaging techniques, etc. Significant progress has been made in brain tumor segmentation despite the difficulties. Machine learning and artificial intelligence breakthrough have played a major role in this, and medical photos are since prone to noise, so we can use multimodal segmentation here, or networks like convolutional neural network. We can apply the algorithm here, and the demand for segmentation techniques that can deliver quick findings without sacrificing accuracy in situations where real-time decision making is essential, as there will be surgery, so we need to make a real-time decision rather than segmentation and accuracy. So there are some limitations to it. And next I move on to the lung cancer part. So lung cancer is one of the biggest fatalities related to cancer related issues. So in order to segment lung cancer, we must take spatial awareness into account. When segmenting lung cancer, spatial awareness requires using the image's anatomical relationships and surrounding context to direct the segmentation process. This method recognizes that a tumor's characteristics are influenced by surrounding structures. So spatial configurations as well as intrinsic traits are taken into consideration, and there are something like lung acetyl CoA, lung squamous lung cancer. So this all goes under the dealing with intrinsic variety in tumor forms and sizes, and there are models capacity to distinguish, and spatial prior incorporation. This segmentation process is guided by the incorporation of anatomical priors such as lung shape models, location of airways and blood vessels, and pleural surfaces. So these prior store spatial relations that can be used to define tumor boundaries more precisely, and thus how we have implemented the methodology. That's it all from me. Thank you.
Assalamu alaikum. My name is Mohammad Saim Khan, and I am explaining the accuracy and our future plan in this paper on this paper. As you know, we use the CNN model. We created a sequential class in the Keras from Keras, and we added different layers such as convolutional 2D, a flattening layer, and a flattening layer, etc. To maintain our model. From this model, we get a accuracy of 89, validation accuracy of 89.81%. We run the epoch for 30 times, and we can see that in each epoch we get from epoch 0 to epoch 5 we get a very high accuracy. Our accuracy increased a lot, and from that time from that time it was increasing a little low, but that we throughout all the epochs we get our accuracy has increased a lot. To be we tried our best to do this, and also there are some shortcomings of our projects, so we are thinking to do this give this paper a lot of time, and as a result we are focusing on some of our future plans. If through in the paper we wanted to work on the spatial features, and also on the spatial features, and then we wanted to given classifications of the tumor and different cells. Also, we wanted to do some data pre-processing for the multimodal images of different types of cancers. So we will be using our time to we will be using we will be using the different data pre-processing model, like as augmentation and rotation for the pre-processing, and also we will be giving we will be for special features detections we will be use different segmentation like say sentimental segmentation. This will I think help us a lot in the future. And we are that's it from my part. Assalamu alaikum.
Hi, my name is Rudra. My ID number is 19301104. The project we are presenting is spatial awareness of cancer cells using segmentation. The part I am covering is the conclusion part. In conclusion, the accurate segmentation of cancer cells using spatial awareness holds significant promise for advancing medical diagnostics and treatment strategies. By incorporating spatial context into segmentation algorithms, researchers and medical professionals can better identify and understand the intricate distribution and relationships of cancerous cells within tissue samples. This enhanced comprehension could lead to more targeted therapies, improved disease monitoring, and a deeper understanding of cancer progression. As technology continues to evolve, the integration of spatial awareness in cancer cell segmentation has the potential to revolutionize the field of oncology and pave the way for more effective and personalized patient care. Thank you.